Good morning, everyone. So today we are going to start a new training on the Microsoft SQL Server. So a brief about me, myself Vijay Rathod, and I am a Microsoft SQL Server developer with 10 plus years of experience in building high performance scalable databases. I am skilled at the query optimization, system tuning, designing solutions that ensure the data integrity and support critical business operations. So today we will go through the theory and mainly focus on the practical skills that you need to be effective SQL Server developer. So my goal is to make these complex topics accessible and directly applicable to your works. Let's start it. So this is the roadmap for today's training. So the fundamentals: what is the SQL Server? DBMS and RDBMS, the core engines, the editions, features and the services, architecture, system databases and physical files, database design, data model, normalization and constraints, the languages of SQL, data types, operation and command sets. After that, we can go through the practical skills like DDL, data definition languages, nothing but the create, alter, drop. Practical set second, that is DML, data manipulation languages, insert, update, delete and truncate. Practical set third, DQL, select, filtering, sorting and grouping. Also we will consider advanced concept like subqueries, identity and sequence objects. So before starting this training, we need a Microsoft SQL Server, so that we can download from this link. Okay, I have here is the link. From here you can download the appropriate software version. This is the SQL Server developer that we are going to use in this training. Let's start it. First we will go through the theory, and after that we will uh, do the real-time examples. So what is the SQL Server? So SQL Server is a relational database management system which is developed by the Microsoft. It's the engine that allows to efficiently store, manage and retrieve structured data. SQL Server is a relational database software used to store the large amount of data or information in tabular form. So the evaluation of, of the database from the files to the relations. So here is the file management system, then DBMS, then RDBMS. In file management, we can store the data in simple text files with no relationship. In DBMS, we store the structured database and some management tools. In the RDBMS, we use the table-based relational, more powerful and consistent database. So here is the continuation of that evaluation part. What is the file FMS? FMS is nothing but the file management system, and it is used to store, manage, and access data from the text files. DBMS is nothing but the database management system. It is introduced in 1970s. In the DBMS, data is the collection of related informations. Database is the base or layer to store the data, and DBMS means it is used to store, manage, and access the data from a database. In DBMS, data is stored in form of table which contains rows and columns. So the example of DBMS is Fox Pro, DBase, and MS access. Now, we can focus on the RDBMS, which is nothing but the Relational Database Management System. So, RDBMS is a software used to create, manage, and interact with the databases that follow the relational data model, which meaning data is stored in the table in the form of rows and column, and maintain the relationship between those tables are defined using the keys, nothing but the primary keys and the foreign keys. RDBMS combines relational feature with the relational data models. So, key points of the RDBMS are tables. In table, data is organized in the table instead of the files. Relation. Uh, which means table can be linked to each other through the relationship using the primary keys, foreign keys. Okay. So SQL. Most means SQL is a structured query language. Most of the RDBMS use structured query language to query and manipulate the data. Constraints. It enforces rules like uniqueness, referential integrity, and the data types. Transaction. Transaction supports the asset properties, which are atomicity, consistency, isolation, durability, to ensure reliable data operations. Example of the RDBMS: Oracle, Sybase, Ingress, Informix, DB2, MySQL, and the SQL Server. So now we can see the key differences between the Oracle and the SQL Server. Here is the table for that. Feature, uh, platform, Oracle. Oracle is a platform independent, works on Windows, Linux, Unix, etc. But the SQL Server is platform dependent and it can only works on the Windows OS. Programs can execute .NET and Java programs. SQL Server executes only .NET programs. Interfaces. Oracle is the CUI, character user interface, and the SQL Server is the GUI, which nothing but the graphical user interface. Okay, so the core concept of RDBMS. Okay, relational databases, SQL languages, transaction, and the security. These are the core concepts of the RDBMS. A relational database means data is organized in the tables, and tables are linked using keys like primary keys, foreign keys. For the customer table, customer ID links with the customers to the order. SQL language. This is how you can talk to the database. Means you use SQL to select data, insert new record, update record, delete record, and much more. Transactions. SQL Server supports transaction to make such sure operations are reliable. Make sure operations are reliable. For example, transfer money between two accounts, both the withdrawal and deposit should succeed or neither happens. Security. Using means SQL Server uses the authentication, login credentials, encryption, and role-based permission to keep data secure. Uh, Now the DBMS features. Following are the DBMS features: the redundancy and inconsistency, security. Security can be provided through the authentication and authorization, data integrity, and the atomicity. In a transaction, a set of transaction is nothing but a set of SQL commands. Uh, Either all command executes or none of them executes. A transaction is unit of works. The It guarantees asset properties, and asset properties nothing but the atomicity, consistency, isolation, and durability. RDBMS features. In the RDBMS, we can store large amount of data. We can use the SQL, that is structured query language, for the means retrieval of data or inserting data or updating data. We can join multiple tables, okay, and it supports relationship between tables like one-to-one relationship, one-to-many relationship, many-to-one relationship, and many-to-many relationship. So the data models are used to define different ways of storing information in the database. There are three types of data models as following. First, the physical data model, conceptual data model, and the logical data model. So the physical data model defines how data is physically stored in the database. Conceptual data model defines what data is stored and relation between the data, often displayed as a diagram. The most famous example is the entity relationship diagram. Logical data model defines what data is stored and the relationship ships existing between the data. There are five types of logical data model. Those are hierarchical data model, network data model, relational data model, object data model, object relational data model. So the logical data model continues. Hierarchical data model. Okay. Here is the diagram how the data is stored. Okay. Consider means in hierarchical data model, data is stored in a tree-like structure and it supports one-to-many relationship. Example, IMS, Information Management System. In the You can see the diagram. Here is the organization, that is Tech, and in our organization we have different project like HMS, CRMS, HRMS. So one organization have multiple projects, means one-to-many relationship, and multiple pro means one project have multiple employees. Okay, like HMS, for HMS project, Ram and Vijay are the employees. Oh, those are working on HMS project. For the CRMS, Ajay, Sanjay, and Surya, those are the employees working on the CRMS, and the HRMS, Anil and Sunil are working on those project. Okay, so here project is one, but it has multiple employees. In the CRMS project is one, multiple employees are working like HRMS. Okay, now come to the next logical data model, which is nothing but the network data model. So in the network data model, data is stored in the tree-like data structure and it supports one-to-many and many-to-one relationship. In this model, data access and manipulation are very difficult. For example, information data stores, IDS. Okay, let's see this diagram. Here is Tech is the organization. Okay, in Tech, we have different projects like HRM, CRM, and HRMS. Okay, now here it maintains one-to-many relationship. Okay, so in HRMS, HRM have different employees, and here we maintain the one-to-many relationship. Okay, we in HRM employees are different. Okay, like Vijay, Vinay, and Akhil. And in CRMS, uh, Akhil and Surya are working. So here Akhil is common for the HRM and the CRMS. So The multiple project can have same employee. Okay. Same is for the CRMS and HRMS. Here Surya is common for Surya is common for CRMS and HRMS. So it maintain many to one relationship. Okay. So likewise, it is very difficult to manage. Third logical model is relational data model, and introduce it. This model is introduced by the EF Code in 1970s. He introduces 12 rules that relational databases should follow, and in this model, data is stored in rows and columns. Example: SQL Server. Object data models. It is used to implement object-oriented programming concept. Example: Cactus software and the object store. Object relational data model. It is the combination of the object and the relational data model. Example of Oracle. So we have a different SQL Server editions. Okay, Microsoft offers different version for different needs. Choosing the right one is the key architectural decision. So following are the editions of the Microsoft SQL Server. The first one is the SQL Server Express, SQL Server Developer Edition, then SQL Server Standard Edition, and SQL Server Enterprise Edition. In SQL Server Express, it is the free and lightweight, and it is perfect for the learning, small project, and the lightweight applications. SQL Server Developer is a free and has all enterprise features, but it's licensed only for a non-production development and testing. SQL Server Standard, the workhorse for many mid-sized business, offering a robust set of core features for production use. SQL Server Enterprise, the top tier edition with the advanced performance, security, and the high availability features for critical systems and mostly used for the productions. A brief history about the SQL Server. Okay, so we means SQL Server was introduced in 1989, but we can consider the stable versions since 2000. Okay, so SQL Server version, internal version, release year, and the features. The SQL Server 2000, which has the internal version like 8.0, and it is released in the year 2000. Here are the features like it supports the XML supports indexes, views. Okay, XML supports index to views, user defined functions, cluster improvement. Then next SQL version was released in the year 2005 as internal version 9, and the SQL Server as 2005, and it has the features like SQL Server Management Studio, CLR integration, dynamic management views, service broker. Then in year 2008, SQL Server 2008 was released with the internal version of 10.0, and it has the feature like data comparison, policy based management, improved security. Then in 2010, 2008 R2 with the internal version 10.50 was released, and it has the feature like BI enhancement, master data services, scaling out reporting. And in year 2012, the SQL Server 2012 was released with the internal version of 11, and it has key feature like always one, availability groups, columns, store indexes, TSQL improvement. In year 2014, SQL Server 2014 was released with the internal version of 12.0, and it has the feature like in-memory OLTP and the buffer pool extension. In the year 2016, the SQL Server 2016 was released with the internal version 13.0, and it supports means its features like it has support for JSON, it has support for temporal data, row level security, strength and database. In 2017, SQL Server 2017 was released with the internal version of 14.0. It supports means it has the feature like Linux support, Python integration, graph database supports. In year 2019, SQL Server 2019 with the internal version 15.0 was released, and its key features are like big data clusters, intelligent query processing, enhanced security. And in year 2022, SQL Server 2022 with the internal version 16 was released, and its key features are Azure integration, cloud linked features, enhanced disaster recovery. So, what makes SQL Server powerful? So the following points makes SQL Server powerful, like TSQL, Transact SQL, SSMS, high availability and disaster recovery, .NET CLR integration, business intelligence tools, and scalability. Microsoft's powerful extension of SQL, adding programming like logic like stored procedure functions and error handling. Okay, SSMS is it is nothing but the SQL Server Management Studio is your command center. Okay, SSM is nothing but the graphical tool to manage databases, run queries, and monitor performance. High availability and disaster recovery. Its feature like always on replication and failure clustering helps a system running even if something fails. .NET CLR integration allows you to write database object like store procedure and function using the .NET languages like C#. Business intelligence tools, integration with tools like SQL Server integration services, reporting services, and analytical services for ETL, reporting and analytics. Scalability. It handles a small databases to huge enterprise system with the terabytes of data. So inside the management studio, you see the following objects, means following things like object explorer, query editor, register services. So object explorer is your main navigation tree used to manage all the database servers and their objects like databases, tables, security, and it runs on the port 1433 by default. Query editor. Uh, this is the window where you can write and execute the SQL commands, and you can press F5 to run your script or your query. Registered servers allows you to register and manage connection information for multiple servers, making it easy to switch between them. So you can create an instance or a copy of database servers. Click on view register services, right click on local server groups, new server registration, server name like my server one, connection properties tab, select the database and save. So we can see this in practical. So here, okay, let me show you. This is the object explorer. Okay, so in object explorer you see the databases. In the database here is a database name. Okay, one database I have already created. It has the security features, means we can provide the security by using this logins, server roles, credential audit, SQL servers, specification. Okay, it has the server objects like backup, link servers, triggers, replications, and polybase management. Okay, here you can give the policy. You can set the policy here and the profiler. Okay, this is the object explorer. Now the query editor. Okay, second one is the query editor. So from here or from here, okay, you click no from here, if you click on this new query, then the query editor is will open. Okay, and here you can write your queries like select start from. Let me check the table in the ABC table. Oh, I don't have any table here. Okay, so like employee. Okay, like you can write your queries in the query editor and the register servers. Oh, from here you can connect to integration services. Okay, in the from the view, go click on the register servers, and here you can see the database engine. Okay, and the local server groups that we have already discussed. Okay, now okay, the types, the SQL Server platform services or the server types in SQL Server. There are different server types in the SQL servers, nothing but the database engines and analytical services. Okay, this is the default server type, database engines, and it is used to store, manage, and access the data from the database, and it works with the online transaction processing databases. And in any .NET projects or application will be database is used. Analytical services. It can be called as a data warehouse, and it is used to maintain old data of any company or business, and it uses the online analytical processing database. The reporting services. Uh, it is a reporting tool which used to generate the reports in the various formats and the types of reports like standard report, ad hoc report, embedded reports. The integration services. It is used to transform or used to convert data from one format to another format. In integration services, 27 transformation can be done, and it is called as ETL, which is nothing but the extract, transform, and the load. System databases in SQL Server. There are four types of system databases: master database, model, MSDB, and the temp databases. Master database is used to perform the user and administrative tasks and used to manage SQL servers. All the system program or predefined program will be in the master database model. It is the template for the new database. Based on the properties of the model database, new database will be created. MSDB stands for the Microsoft databases and used to store the job history for SQL Server agent. Job history will contain the SQL commands executed by the users, and it is used for the data recovery. Temp database means temporary databases. Whenever SQL Server is started, the temp DB will be created. It is used to store temporary data and the temporary store procedures. So let's see where we can find this four databases in the SQL Server Management Studio. Okay, Now if you go here, okay, click on the database, expand these databases, okay, system databases. Here you can find the master database, model database, temp data, emsdb database, and the temp databases. Okay, now so what is the database and where data physically lives? Okay, before that, SQL Server instance can contain up to 32,767 databases. Okay, here this diagram shows the types of files. Okay, the primary data files and the log file. In the primary data file, we can store the tables, views, indexes, synonyms, sequences. So primary data file, we can means it has the extension of .mdf, and it contains the startup information of the database. It is used to store the tables and other objects. The file extension is .mdf. Log file, transaction log file. uh, it is used for the data recovery. If the data is lost, to get back it again, then log file is used. The file extension is ldf. And the secondary data file, if the primary data file memory is full or no space is there, then secondary data file can be created to store the tables and other objects. So logical files versus physical files. Logical file will store in the SQL Server or in the SQL Server Management Studio, and the physical file will store on the operating system. Logical file contains the reference or the memory address of the files in the OS. So you can find the files in the below location. Like for means for my local is my PC name, changing in it. Okay, C program files, Microsoft SQL Server. This is the version of SQL Server with the name, PC name, MS SQL data, and in the data you can find two files. One is means database name.mdf. This is a primary file, and this is the ldf file. Now, how we can design a database? For the designing database, we use the normalization. So normalization is the process of organizing your tables to reduce the data redundancy and improve data integrity, and it involves decomposing large complex tables into smaller and more manageable ones. Why the normalization is important, or the advantages of the normalization? Using normalization, redundancy can be reduced, inconsistency can be avoided, and the related data is stored in the tables. What are the normal forms? There are four normal forms, which are first normal form, second normal form, third normal form, and the boys quad normal form, which is the BCNF or the 3.5 NF. Let's take the example of this. Okay, so unnormalized form. Okay, this is the bad design. So all the data. Okay, so let's take the example of orders raw table. Okay, so all the data is jammed into one table, that is the orders raw. Let's see the structure of this table. Okay, it has the order ID, customer name, customer address, product 1, product 2, product 3, and the total amounts. Okay, so here we have below problems like the repeating columns. This table has the repeating columns like product 1, product 2, product 3. Customer info is repeated for every orders. Okay, and the updates are messy. If address change, must update everywhere. So for to work on those, we can use first normal form, second normal form, third normal form, and BCNF. Okay. So in the first normal form means first normal forms means all the columns in the table must be atomic. Means every column should have a single value. Repeating groups or duplicate columns are not allowed. Okay. Using first normal form can increase the data redundancy as there will be a multiple rows with the same data, but each row has a whole each row now has a whole unique values. Okay, so now let's split that orders raw table into two tables like orders and the order table. In the orders table we have the order ID, customer name, customer address, and the total amount. And in the order tables we have order details ID, order ID, and the product ID. Means here order ID is the primary key in the orders table, and in the order details order ID is foreign key, means it's related to the order table. So in the first normal form we fixed. So in this each product is a row in order details table. We have removed the duplicate from the orders and not multi-valued fields. Okay, but the problem here is that we still have the redundancy in the customer data in order table. Okay, now come to the second normal form. In the second normal form, all the column in the table should functionally depends upon the primary column, okay, in the table, and make sure it follows the rule of first normal form. Partial dependencies are not allowed in second normal form. So here the problem is that product name depends on the product ID, not on the full, that is order ID, product ID key. So here are the tables, customer table and the order table. Now along with we have created one table, that is the products, product ID, product name, price, and also created another table, that is order details. In the order details we are storing order ID, product ID, quantity, primary key, order ID, product ID, foreign keys, order ID, that is referencing to the order ID of the orders table, and the product foreign key product ID references to the products product ID, means product tables product ID. So in the second normal form what we fix, uh, a product tables has the product information, orders table links to the customer and the products, and no partial dependencies. Third normal form 3NF. Now third normal form should follow the rule of second normal form, and all the columns should depends upon the primary key column in the table. In the third normal form, transitive dependencies are not allowed. Transitive dependency means non-key column will depend upon the another non-key column in the table. Suppose we add zip code incorrectly like below, means alter table customer add zip code varchar 10 city. Now city depends on the zip code, not on the customer ID. That violates third normal form. So the correct design is means correct database table design is that we create a new table that is zip codes, and we can drop the columns from the customer table, and we can add zip means we can add zip code uh, to the customer table. Okay, referencing to the zip codes of the primary zip code. Okay, now city depends only on zip code, not directly on the customer. Transitive dependency, customer ID, zip code, city is removed. Okay, now the last one is voice code normal form BCNF 3.5 NF. BCNF is the advanced version of 3NF, and it is stricter than 3NF. A table should be in a BCNF if every functional dependency of X equals to X such that Y, where X is the super key of the table. Okay, for BCNF, the table should be in a third normal form, and for every functional dependencies, the left hand side is a super key. Every determinant must be a super key. Note: functional dependency X such that Y means if you know X, then you can uniquely determines Y's value. Super key means a set of attributes that can uniquely defines every row in a table. Now, order ID, customer name. It is okay because order ID is primary key. Now, order ID, product 1, product 2, product 3. It is also okay because means order ID holds the information of product. Now, customer name and customer address. It violates the BCNF. Customer name is not a super key because a customer can have multiple orders. Total amounts depends on the product transitive dependency, violates BCNF. Conclusion: this table does not satisfy the BCNF because of customer info dependency. Customer name depends on the customer address, and the product stored in the multiple columns, that is product 1, product 2, product 3, and creates repeating groups and transitive dependencies to the total amount. This table is not satisfy the BCNF because of the customer info dependency and the product stored in multiple columns. To fix this, we can decompose the table into multiple tables like customer tables. Okay, in the customer table should uniquely holds the customer information. Then we can create a product table, order tables. In product table, it store the all details of the product, and this orders table store the order level information. Okay, now, and also we'll create another table is order details, and it is links to the orders and the products. Okay, here order ID, product ID, quantity, primary key order ID, product ID, foreign key order ID, that is the primary key of the order tables. Okay, and the product ID references to the product table. So here is the how BCNF we have fixed: customer table, product table, orders, and order details. So below diagram includes all those tables like customer, product, orders, and order details. and all are in the BCNF. Okay, now let's start the database design using the constraint. Okay, so contents, what is the constraint? Constraints are used to give the condition or rules on the table so the valid and the meaningful data can be stored in the tables. Constraints can be given at the column level or at the table level. If one constraint is given for the column in the table, or if two constraints given for one column in the table, then column is it is at the column level constraints. If one constraint is given for the group of columns or two columns in the table, then it is the table level constraints. So syntax for creating constraints, like constraint name. There are different types of constraints like unique, not null, primary key constraint, check constraints. Then foreign key constraints. Uh, the constraints will works only on insert and update commands, and it will not work on the delete commands. So how you can check the constraints? So for this syntax, you can use the sp underscore here constraints, then the table name. If you execute this query, this command in the query editor, you will see all the constraints on the table. You can delete the constraint using alter table command and the drop constraints type of constraints. So unique, there are five types, means unique constraint, not null constraints, primary key constraints, foreign key constraints, check constraint, default constraints. So unique key constraint accepts new unique values, and it allows one null values. Not null accept duplicate values, but it will not accept null values. Primary key constraint is the combination of unique and not null constraints. So primary key constraints accepts only new values and will not accept null values. On a table, we can have only one primary key. In the primary key, two key will be there, that is candidate key and secondary key. Candidate key uniquely identifies each row in the table. If column contains unique values or different values, then it is called as candidate key column. And a table can have multiple candidate key column, but only one can be chosen as the primary key. Secondary key, it uniquely identifies each row in the table when the primary key fails. The foreign key, it is used to create the relationship between tables and maintain the referential data integrity. It is used to create a child or dependent table. Referential data integrity, nothing but the values in the foreign key column of one table refer to the primary key column value in another table. Check constraints, it's ensure that the value in the column meets a specific condition. Default constraints, it using the default constraints we can specify the default value of for the column. Composite key, it will work with the multiple columns in the table. It will works with the composite or mixed data. If primary key is given for two columns in the table, then it is called as the composite primary key. Next is the what is the data types, okay, and what are the data types in SQL Server. There are different data types in SQL servers like integers, characters. Okay, integer has different subtypes like thin integer, small integer, int, and big int. Characters also divided into different subtypes like char, varchar, n varchar, nchar text, and text, n text. So here n stands for the national characters set. So char is the fixed length and it always uses the full amount of allocated memory. Varchar is a variable length. It only uses the memory for the character given. It prevents the wastage of memory. Char and varchar uses the ASCII code. Nvarchar, nchar and nvarchar uses the Unicode. Okay, which supports multiple languages. Unicode uses 2 bytes per character. Float. Float is also uh, float has float also has the different subtypes like float for floats, decimal, small money. Then binary. It returns. It has the bit values true or false, and also has the image. Large objects. Varchar max. Okay. In varchar max. Dead time. It dead time also has the different subtypes like small dead time, date, and time. Also has the miscellaneous data types like SQL variant, XML table. Can SQL variant stores any type of data. XML is used to store the data in XML format. Table is used to get the records from a table. Operators in the SQL servers. There are different types of operators like arithmetic operator, relational operator, logical operators, spatial operators, concatenation operators. So here now let's create a database practically. Okay, so I'll show you how to create a database using this means using the comma query, and also I'll show you how we can create a database from the object explorer. Okay, let's create first from the object explorer. Here you can create a right click on the new database, and here you can give the database name as empdb. Okay, now it will create uh, two files. One is, yeah, here you can see the mdf file and the log file. Okay, now database is created. Also we can add the secondary file to the existing database. Okay, or we can remove the database using this command. We can drop the database. Here are the SQL command sets which we can use. So the data definition language, it works with the column structure of the data. Those are the create, alter, drop. Data manipulation languages works with the rows and records, and those are the insert, update, delete. Data control language, and these are the grant and revoke. Grant gives the rights to a user, and the revoke removes the rights from a user. Transaction control language, commit and rollback. Commit means it saves changes permanently. Rollback means it cancels the execution of the commands. Means one command fails, then all the commands reverted back. The data retrieval languages is select, which we use to get the records from the table. So here you can see the diagram, the types of DDL, DML, TCL, DQL, and the DCL. So the basic SQL command to view the tables in the current database. Here, this is this. Okay, we don't have any tables in this database. Okay, let's switch to the database. Okay, now let's create a table. emp int alumni. Okay, as of now we can give these two columns. Okay, and we can save table as emp. Okay, now one, we have created a table. Here you will get the emp table. Okay, type user defined type id. Okay, so we are in DB. Okay, and suppose you want to go to the different database ABC, then you can use the command like use ABC. So it will switch to the ABC database, and can write a query for that database. Okay, here is the syntax for creating a table. Create table, table name, column name, data type. Okay, so table name and column name should not have spaces, and uh, we can use underscore to join the names, to join the words. Table name or column name should start with the characters. A table name can contain uh, thousands of columns. If you want to see the structure of the table, okay, you can use this command. Let me switch back to the empdb. Okay, now here emp. Okay, here you can see the name of the table. Okay, that is the type, owner type dbo, columns emp id, emp name. Table, this table don't have the identity. Okay, so for inserting records into the table, you can use insert command. Insert into table name, values, then value 1, value 2, or insert into the table name, column name, then values and the value. Now I that is the you can insert data using the query. Okay, so now I am going to insert the data using this editor. Okay, so for this you can click on the edit top 200 rows. So emp id is 1, name is Vijay, 2, name is Sanjay, 3, name is no. Okay, so I have inserted the data using the object explorer. Now let me get the data from this table. Okay, so let's start from emp. So here I get the data, employee id, employee name. Okay, To view the records in the table, you can use the select star. Okay, or star means it will gives all the columns, or if you want to see the particular columns, then you can specify the column name from the table name like this. So it gives us all the columns, that is employee ID and employee name. And suppose I want only EMP name, then I'll, so it will gives me the only EMP name. Okay, two, we can delete the table using the drop table command. Okay, drop table name EMP, or you can right click, and if you click on this delete button, it will delete the data, sorry, delete the table, drop table. And if you run the query, then it will give the exception like the invalid object name EMP, means table is deleted. So following are the operate clauses and the operators, that is null. It works with the null values. So it replaces the null values with the specified values like operators. It is used with the column containing the characters, okay, or pattern matching. So uh, there are two wide card used in the like operator like underscore. It is used for the single character, and underscore percentage means within we can define a set of characters. In operator is used to specify the multiple values in where clause. Between and at is used to specify the range in like minimum and maximum values. Is used to work with the null values. And order by is used means order by is used to show the records in a ascending or descending order. Okay, here are some advanced statements like to create a duplicate table. Okay, to create a duplicate table, you can use the select star into duplicate table name from the original table. Fetch and offsets. Okay, uh, it is in fetch and offsets are introduced in SQL Server version 2012 plus. So offset is used to skip or ignore a specified number of records, and fetch is used to display specific number of records. Okay, so example, select the last three records from the EMP table. Select star from EMP, order by EM employee number, offset 3 rows, fetch 3 rows. Okay, let me create a table. Okay, first let me create a employee table. Again, right click, create. Number, name. Okay, name. Okay, now I am setting, marking this as the primary key column, and also I am adding the identity here. Okay. Now let me add the records into this. When we set the identity, then we are not adding the values for this column. It is automatically incremented by 1 and it is started from the 1. Okay. Now let's uh, see the example of offset and fetch. So display the last 3 records from the MP table. Okay, for that we are going to use the fetch and offset. So it will display as the 456. Okay. Then group by statements. Group by statement is used to group the similar values or duplicate values existing in the table. With the group by statement, group or aggregate function are used like sum, average, max, mean, count. Here is the syntax. Select ename from EMP. Here I don't have any duplicate records in the table, so that's why it gives us the unique values. Now group by extension with rollup and with cube. So with rollup is used to display the subtotals and a grand total based on the first column in the group by statement. Okay, here is the example of the group with rollup. So we don't have this. Okay, over then sum of salary. What is the salary? So, group by okay, this is giving us a result like this. Now with the cube, it is used to display the subtotals and the grand totals based on the multiple columns given in the group by statements. Here is the example. Okay, same with cube. Okay, here it queues the records using the queue. Alter commands. Okay, so alter command is works with the columns, and it is used to modify the definition or structure of the table columns. Here is the syntax. Okay, add column name. Suppose I want to add department column. Here we can. Okay, column is created, so we can check here the department is name. Department name is null. Add is used to add a new column or constraints. Alter column is used to change the data type and size of existing columns, and drop is used to delete the column or constraint. To change the data type and size of existing columns in the table, here is the syntax. Alter table name, alter column name, then the data type, new size. To see the definition of the columns in the table, okay, so it sp underscore help, then table name. Let's see this. It gives all the details about the table. To delete a column, we can use the alter table name, then the drop column and column name. Okay, to change the column name, so this is the we can use the sp underscore rename, then the table name dot old column name with the new column name. Here is the example. Update. Okay, so update command is used to modify the content existing in the table and used to perform the calculations. It works with the rows and the records. Here is the syntax. Okay, suppose I want to update the salary. Okay, department name. To IT for employee 1. So here is one row affected, and if we run this query, the department is updated. Okay, here computed tables can be created. Okay, like create table employee name, so employee ID, employee name, employee number, employee name, basic, TA. These are the columns of the table. Delete command. So delete is used to delete delete table, okay, or the column. To delete the duplicate records from the table, you can to you can perform the 3 steps. Okay, you need to do the 3 steps. The first is create a duplicate table. to store only unique value, to store the unique records. Okay, for that you can use the syntax select distinct star into duplicate table name from the original table name. Then you can delete table which contains the duplicate records. For the deleting table, you can use the command, and after that, lastly, you can rename the duplicate table with the original name. For this, you can use this. So truncate command is used to delete all the records in the existing table. Okay, truncate table name. So the difference between the delete and truncate is delete can remove one or multiple or all the records based on where condition. Truncate removes all the records. Delete and truncate command will delete only the records from the table, but the column name will exist in the table. Rollback can be used with the both delete and truncate. Delete command will delete all the records in the table, but the identity will be reset. Identity will not reset. To reset the identity, tbcc command should be used. Truncate command will delete all the records from the table and will reset the identity. When new records are given in the table, it will start with the initial value or starting value. So for viewing the columns or record using the wizard, you can go to the view, right click on Explorer, double click on the database, rename, database name, tables, right click on the table name and edit top to 100. Same like this. Here is the employee table name and click on the top 200 records. So you can see all the data in that particular table. So identity is nothing but it is used to generate the numbers in the sequential order, and those values can be used while inserting new records into the table. So here is the syntax: identity, the initial value or the seed value, and then the increment value. So for this table we have added the identity using this wizard. Okay, to see the current identity. So if you want to see the identity on the table, you can use this command like here is the 6 means we have 5 records, 6 records. If you want to reset the identity, you can use this syntax. Okay. From 10, reset value is 1 and the value, a new value is 10. Okay. Now identity is oh sorry. Okay. Now current identity value is 6. Okay, let's add the record into the CMP table. Okay, let's go to this. Uh, Edit to 100. Now add Rahul, salary is 50,000, sorry 5,000, department is IT. Now it's the seed value is reset to 11. Okay, identity is reset to 11. So to disable identity, you can use the syntax. Here is the table name. It is used to disable the identity, and to enable identity you can use the syntax. Okay, now sequence. So the sequence object is introduced in SQL Server 2012. So it is used to generate the numbers in sequential order, and those values can be used in a table while adding records or inserting a record. So it is used to overcome the drawback of identity. A sequence is a separate object and can be used with the existing table. Identity cannot be can be used while creating the table, but cannot used with the existing table. With the sequence object, it will create it will be created first and will be used in the table while adding records. A table can work with the multiple sequence objects. So here is the syntax to create a sequence. Let's go this. Okay, I'll give this as my sequence. Start with value 100, increment by 1, minimum value is 100. So this 200. Okay, now sequence is created. My sequence is created. Okay, let's see. So, means now there is two options, that is cycle and cache. Cycle means when the sequence reaches to the end max value, then it will start with the beginning values. Okay, by default sequence will access values from the database, and this will with this execution performance will be reduced. By using cache, the sequence object values will be stored in the cache memory or a temporary memory. So now we can create a table. Okay, the table is created. Now we can add the records. Okay, row is created. Let's check. value is added. Okay, so here we haven't set the identity, we use the sequence. So you want to see the sequence in the current database. For this you can use this syntax. So it gives all the sequences. So to modify sequence you can use the syntax, and to delete sequence you can use the drop sequence name. Okay, constraints. So example of constraints, we can use the parent child table. So here is the department table. You can create this. Okay, now you can create a child table. Okay, department is created and EMP department is created. Okay, so here department number is primary key, and in the department table department name number is foreign key, and that is referencing to the department tables department ID, department number. So to add constraint to an existing table, you can use the syntax. Okay, here is table name like DP. No, can use this EMP. Constraint name something like, we can keep this as name, on column name EMP. Okay, so using the syntax we can add a constraint to the existing table EMP. Here is the foreign add the foreign key constraints. Here we have added the foreign key references. Here the table level constraints. Okay, let's create a table using the syntax. Okay, table name e number EMP name, constraints primary key, e name and e number and e name. Okay, for subqueries, subquery is a query within another query is called as subquery. So means let's check practic in the real time how we can use the subqueries. So write a query to get the second highest salary from the EMP table. So for this we can use this syntax. Okay, max salary. So here 20,000 is the second max salary. Okay, you can check 30,000. Okay, this is the highest salary, then the second highest salary. Now we can take another example, like write a query to get the nth highest salary. In our case we can get the fourth highest salary. So for that you can use this syntax. So you can check the first one, second one, third one, and this is the fourth one, highest salary. So you will get this result using the subquery. Now the nested subquery. So nested subqueries are the query within another subquery is called as nested subquery. So nested subquery contains three select statements, and they are main query, subquery, and the nested query. So let's see the real-time example of this. To get this, to get the write a query to get the third highest salary. Okay, so for this we can use this syntax. So main query is this. This is the first select statement, second and third. So if you run all this, okay, here salary is not called. Okay, we have salary column. This is the third highest salary. You can check using this, the first highest, second highest, and third highest salary. It gives us the third highest salary. Now another most important question asked in interview is this: write a query to get the second highest salary. So for this you can use the syntax. This is the second highest salary for the employee Sanjay. So as of now, this is all about the basics of the SQL Server. So in the next video session, we will see some advanced features of the SQL servers. Okay, till now, goodbye.